Alright, hey, so we're gonna go through the process of solving some logarithmic equations. And really what it's gonna involve is just keeping in mind what a log function is. Logs are the inverses of exponential functions. So, and the kind of the model I keep on my mind to keep the relationship between exponential functions and logarithmic functions straight, which is a very concrete example. 10 to the power of 2 equals 100. Therefore, log with a base of 10 of 100 equals 2. Because to what power do I have to raise 10 in order to turn it into a 100? I have to raise it to the power of 2. Right? So we can use this relationship to rewrite logarithmic equations in a way that makes them easier to solve. So, for example, log of x equals 2. Right? Okay, well, is there another way to write this? So first of all, if it's just log, there's no base written down here. That means it's log base 10. Log base 10. So now I'm going to write that in there. Okay, so what this means, alright, so 10 squared equals 100. That means log base 10 of 100 equals 2. So what this is saying is, to what power do I have to raise 10? What it's saying is, what I raise 10, the power that I raise 10 to is 2, and that turns it into x. So I could rewrite this like this. 10 squared equals x. So of course x equals 100. It's 10 squared. So log, um, so I'm raising 10 to the power of 2, and that gives me x. So, or we can see here, log base 10 of 100 is 2. All right, so let's try one with a little bit. It's a little bit more challenging. The natural log of 2x plus 1 equals 7. So natural log, that means log base e. So what this is saying is, I raise e to the power of 7, and what I get is 2x plus 1. That's what that's saying. Well, now it's algebra. So your calculator should have an E button. E is a special number. I think it's, what is it, 2.71 something? Well, wait, let me just find out actually. Yeah, 2.7. Okay. So e to the power of 7 is 1096.6 and some change. So 1096.6 yada yada equals 2x plus 1. So I could just subtract 1 from both sides. So 1095.6 is equal to 2x, and then I can divide by 2, x equals whatever that is divided by 2. Subtract 1 divided by 2, 547.8. Boom. Alright, let's try another one. So log base 3 of 3x is equal to 3. What that's saying is, if I raise 3 to the power of 3, I get 3x. Throws 3 to the power of 3 equals 3x. 3 to the power of 3 is 27. 3 squared is 9 times 3 is 27. It's equal to 3x. So divide both sides by 3. X equals 9. Not too bad. So here we've got log base 10 of 2x is equal to log base 10 of 100. Alright, well, if log base 10 of something is equal to log base 10 of something, those somethings must be equal. So 2x equals 100. In other words, if I raise 10 to this power, I get 2x. And if I raise 10 to this power, I get 100. So 10 to the power of something equals 10 to the power of something. Well, uh, if I have log of the same base of something equals log of the same base of something, these somethings have to be equal in order for the equation to be true. So just do that there. So x equals 50. So here's an example. Keep in mind what log means, um, and keep in mind that the sides of the equation have to be equal. All right. So there's a few different situations in which you can just by knowing the meaning of logs, you can rewrite the situation, and then it becomes much easier to solve.